looking at the review, looking at number 7. A polynomial, so that's important. We know generally what a polynomial looks like. Has a relative max of -2, 3. And a relative min of 4, -3. And no other critical points. So no other places where f prime is 0. Or undefined, but as a polynomial, it wouldn't have had any undefined derivatives anyway. How many real zeros does it have? So there's a max there. I know what that looks like. There's a min there. I know what that looks like. But I can't have a polynomial. A polynomial doesn't look like that, right? It's continuous. And it goes on forever. So it has 3 zeros. I don't know that that's where they're at, but it definitely would have to have 3 zeros. Did that answer your question?
Yes.
Okay.
If it doesn't specify where the endpoints are, do you just assume that it's continuous?
Well, it didn't specify. Yeah, it didn't specify endpoints, and it said a polynomial. So a polynomial eventually goes up forever or down forever on each end. Number 2. What type of point is, and justify your answer. So at x equals -2, let's see, f prime is 0, f double prime is positive, so there's a horizontal tangent line. So it's a horizontal tangent line, but it's also concave up. So I need to draw something that's concave up, but has a horizontal tangent line. So I think I just convinced myself that x equals -2 is a relative min. And then your justify would be f prime equals 0 and f double prime is positive. That's the justify. That's the second derivative test, because we're using the second derivative to figure out what f prime equals 0 means. At x equals 0, f prime is positive, f double prime is negative, or no, f double prime is 0. What does that mean? This one's tricky. I don't know that it's a point of inflection, because I don't know if it changes signs at 0. I mean, over here at -2, second derivative is positive, and over here at 3, second derivative is negative, but it might change 100 times between those two spots. So I think the only answer is it's a possible point of inflection, because I don't know what's happening just left of 0 and just right of 0. So it's trying to bait me into saying it's a point of inflection because the second derivative changes signs, but I don't know that that's happening exactly at 0. So possible POI is as best I can say for that one.
Number 5 is just like a really complicated factoring, right? There's nothing.
Yes, but hold on, let's finish this one.
Okay, sorry.
X equals 3, f prime equals 0, the second derivative is negative. So like the combination of those two things means, what does that mean? It's a relative max. It's a flat spot, but it's concave down, so there's a relative max using the second derivative test. No one asked for one, but number 1 would be a first derivative test, because all we have is stuff about first derivative. So something's going on at x equals 3, and the reason is f prime changes positive to negative. Number 5?
I don't need to do it in class. I can probably understand.
Okay. I mean, the trick is it would sure be nice if we could factor something out first.
Yeah.
And we can. 3 will divide into all of those. 4x squared minus 24x plus 105 divided by 3 with a calculator maybe is 35. I may as well keep going. Usually the smaller or like the closer numbers are the best bets for the guesses. So I'm going to start with 2x and 2x. I switched to a pencil in case I mess this up. The signs will both be negative, so that's good. We're not guessing around with signs. So both of the factors of 35 will be multiplied by 2. And then factors of 35, there's not too many of them. 5 and 7. So that'd be negative 10 and negative 14. Yeah, that would work.
Can you do like numbers?
So x equals 7 halves, x equals 5 halves. And what about this 3 out front? Right, it's like, what about it? It doesn't add anything to our solutions. If there was an x out front, then we'd have x equals 0. But just a number out there, that doesn't add anything for us.
6.
Number 6, discuss the concavity. So what goes off in your brain when you see concavity? Second derivative. In fact, the sign of the second derivative. So first derivative would be 8x cubed plus 6x. If I was worried about maxes and mins or increasing, decreasing, I'd pause there and do a lot of work. But I just want concavity, so I can go to the second derivative. 24x squared plus 6. And then what next? What do I do with that? Set that equal to 0. Uh-oh. I mean, I guess I can play with this for a little bit, but that's never going to work. So, what does that mean? If there's no places where it's 0, what's going on here? Maybe if we'd have really been paying attention, we'd have seen it here. 24x squared plus 6, that's always positive. Right? Square something and then add 6 to it. That's never negative. The other way to do it would be to say, well, I don't have any possible POIs, so I guess I'll do a number line and it'll all be the same thing. There aren't any intervals. Well, I shouldn't say that. There's one interval, the whole thing. So pick a test point. The second derivative at 0 is positive. So it's positive everywhere. Again, we might have picked up on there. So what am I saying about concavity? F is concave up, always.
I don't know the difference between like the second derivative test and the concavity thing. Like I keep on forgetting that. Like what to do.
So the second derivative test is used to find maximums and minimums. Concavity is only using the second derivative, only worried about the sign of the second derivative on intervals. The second derivative test, you test the second derivative at the critical point, so at points. See if this kind of thing is going on. This is a second derivative test type table. A number line with the second derivative tells you about concavity. Let's see, the only two left are the optimize.
Yeah, For the fencing one,
Uh-huh.
I got the width is 30, which I think other people got, but then I got a length of 60.
So careful how you set up,
Yeah.
because if you label things differently, 3 congruent adjacent rectangular plots. So people could call a bunch of different things L's and W's.
Yeah.
So to make mine match yours, what did you the 4 things? What did you call those 4 things?
I did 4 W's
Okay.
and then 2 L's.
Okay, perfectly okay. So that means your L is the full length,
Yes.
which is fine. Arguably better, because then your area is just length times width. If you make your length just one of those lengths, then your area would be 3 times L times W. That make sense, or is that
Oh, yes.
like some people are going to call this X, but then their area would be XW times 3.
Oh, okay, yeah.
So if you're comparing with friends, you got to be careful. Make sure you set it up the same way. This is how we usually set it up together. So we're probably all close to this.
So on your review thing, like on the answers, it's different.
Did I do it different?
6L or whatever.
I did. I made the L's each individual, and then my area would be 3LW. So the way we've got it drawn here, 2L plus 4W equals 240. Find the dimensions that maximize the area of the garden. And then I know how to ask this question, so it doesn't matter about your L's and W's. Find the total area of the garden. That will force us to have the same answer. Like when I first started teaching, I didn't do that. I'd say find L and W, but then I got to figure out what you called L and what you called W, and now it's a lot easier. Just what's the area?
Okay, I might not finish the question, but I did my homework. It's fine.
Are you good? You want me to keep going? Does anybody want me to?
I got 1800. Is that the like?
I don't have the answers with me. Does anybody remember? Or
It is? Okay, then we're fine. I just
keep going? Okay. So here's the one I want to maximize. So that's the one I want to take the derivative of. I don't want to do it yet because I've got an L and a W, but I've got a helper equation here. I'm going to solve for L, but you could do it. You could solve for W. If I try and do all this in my head, so let's see if I can not mess this up. 120 minus 2W would be L. So area is 120 minus 2W times W. 120W minus 2W squared. I have not done any calculus yet, right? This is all algebra setup stuff. Now I'm going to take a derivative. 120 minus 4W. Set that equal to 0. So W equals 30. I heard you say that, so that's good. Units, 30 feet. But the last step is always make sure I'm answering the right question. Find the total area of the garden. I have an equation that just has W in it, so I could plug 30 in for that. Most people, though, sort of come back to the beginning of the problem and figure out everything, which is fine. So length and width, and my area, my length is the full length, so area is 60 times 30. So yes, 1,800 square feet. Now if you look on the notes that I posted, I set it up differently, so my L would have been 20, but I still would have had the same area. All right. Are you feeling okay about this test? I'm hopeful. I guess the primary thing we added from the last test was the optimized stuff. And most of you did well on the last test. So we added a little optimization, and hopefully we're still good. A few of you didn't do well on the last test, so we relearned that stuff. We add optimization, do better, and we'll do the replacement thing.